Assalamualaikum warahmatullahi wabarakatuh. My name is Aliff Nadzmi by Ahmad Kamal, BE20203. I'm from Group 7, from Section 1 for the subject of Transform Circuit Analysis. And I would like to present about our manual calculation for the project, our group assignment related to the RLC circuit analysis using for the series. So based on the problem statement or the problem that we have, which is the circuit that we have chosen. So the RLC circuit, which is the component is connected in series and stated their value of each component. And also we have the input voltage in a non-sinusoidal form, which is a square wave. And for the manual calculation, okay, firstly we have to get or earn the information from the based on the equation. So for the square wave, we can obtain the function of the input. So when time is 0.5, so what is the function? And so this is the circuit that we need to transform or change from the time domain to the frequency domain. And after we have done this step, which is transform and also have a function, and we need to find the term or the coefficient for the Fourier series form here. So for the A0, AN, and also the BN. Okay, firstly for the A0, after we have used this formula 1 over t integral 0 unto t ft dt, we have a value of A0 is 0. So for the AN, since we get the information which is our t is equal to 1 and omega naught is equal to 2 pi over t, and which is 2 pi over 1, it means that omega naught is equal to 2 pi. So we just put it inside replace the omega naught, and the final answer we have is 0. Okay, next for the Bn, by using the formula given to find the Bn value, we will have a value of negative 4 over pi n for the n value is equal to when n value is odd, but it will become 0 when the n value is even. Okay, then when we based on the previous calculation, we just substitute the coefficient. So we have A0 equal to 0 and also AN equal to 0. So that means we just have a BN. So Ft is equal to negative 4 over pi 1 over n sine 2 pi nt, and the n is equal to 2k minus 1. So by using the form of Ft is equal to A0 plus AN cos n omega naught t plus Vn, so we will obtain the value of AN is equal to square root of AN square plus BN square, and the answer is 4 over pi n when n value is odd, and the angle is negative 90 degree when n is odd. So for the k equal to 1, so we just put inside the here n equal to 2k minus 1. So that means that when k is 1 is n also 1. So A1, we got the result of 4 over pi and the angle is negative 90 degree. Same goes to the k over 2, k equal to 2 and k equal to 3. So this is the spectrum that we have drawn, which is for AN and also the theta n. So for the VST, V1S is equal to 4 over pi angle of negative 90 degree volt is equal to 1.27 the angle of negative 90 degree volt. So here for the B3S and also the B5S. So for the next step, we need to find the current source or the current that's supplied through all the component in the circuit. Since the circuit is connected in series, so the each component will receive the same current, the value of current. So by using the Ohm's law, we need to find the Z total of the circuit and also the V total for the circuit. So for the Z total, for the total impedance, we have this. We have sum up all the component, and here is the Z total. And by using the Ohm's law, we have to divide voltage with our total impedance, and here is the answer. And we just put the N value, and we will have the answer based on our N. So for I1, which is K1, K equal to 1 and N also equal to 1, so we will have 0.065 angle of negative 165.11 degree ampere. So for the I3, which is when K equal to 3, when K equal to 2, N is equal to 3, which is I3 is equal to 0.007 angle of negative 174.95 degree ampere. So for when I5, which is means that K equal to 3 and N equal to 5, we have 0.003 angle of negative 176.96 degree ampere. So here is the Fourier series of the current source or current that supplied through the circuit. And next we have to find the voltage for each component for the R, C and L. So we start with the R first. So R1 is equal to 5 ohms, and so by having the information of the I1, we just use the Ohm's law, which is V equal to IR, and we will have a 0.325 angle of negative 165.11 degree volt for VR1. So for when K equal to 2, N equal to 3, the value is 0.035 angle of negative 174.95 degree volt. So for when K equal to 3 and N equal to 5, we have 0.015 angle of negative 176.96 degree volt. So here is the Fourier series or for the VRT. So for the next, for the component of capacitor, which is C1, so we just use also same method, which is Ohm's law. We will have VC1 is equal to 0.003 angle of negative 255.11 degree volt, and for VC3 we have 0.002 angle of negative 264.95 degree volt, and for the VC5 we have 0.00005 angle of negative 269.96 degree volt. And here is the Fourier series for the VCT. Okay, next for our inductance. For the VL1 we will get 1.23 angle of negative 75.11 degree volt, and for the VL3 we have 0.2 angle of negative 84.95 degree volt, and for VL5 we have 0.14 angle of negative 86.96 degree volt. So here is the Fourier series for the VLT. And next for the power consumed by the component, we have choose is our resistor, which is 5 ohm, and based on the information of that we have, which is VRT and the current. So we just need the V and also the current, and we can use this formula of P equal to VDC multiplied with IDC plus 1/2 Vn In cos theta n tolak theta n or Vn. And so we just use the information listed as above, and the final answer, since our cos theta, our angle is our angle is become 0, which is when cos 0 is equal to 1. So this means that our final value that we have is 10.7 milliwatt that consumed by the resistor. So that's all for the manual calculation, and I will pass for our next member for the simulation.
Assalamualaikum, my name is M.Rifqi Aiman bin Azizan. My metric number is DE200115. I'm from group 7. We will present how to do a simulation for our group project, which is non-sinusoidal AC input signal for RLC by using PSpice. Firstly, you need to open OCAD Capture, which is the PSpice. Then click File, click New, and click Project. Then your screen will appear like this, which is this is the canvas. Alright, then you need to make sure what component that you use for your circuit. So you can get the component by this symbol, this part. This is the wire, and then this is the ground. Right. Let me take what component that I use first. Right, then we need to connect all the component with the wire. Then we need to rotate it. Put it the ground. Connect the ground with the wire. Right, then we need to put the value. This one is -1, 2 is 1, this is 0, TR is 1 milli. Alright, all the value is depend on your circuit, which is especially V1, the input, it depends on your input signal for your circuit. Right, finish all this, and then we need to measure all the parameter, which is the voltage on each component and or the current on each component, and also the power. Alright, to get the value, we just use it. Firstly, we need to create the new simulation profile, which is you can put any name for your file, which is I will put my name is TC project. So after that, I'm already do the new simulation profile. So my simulation profile is TC1. Then from here you can get the output file, which is you need to put what you want to measure. So first, let we measure the V1, which is V in. Click OK, apply, and OK. And then we need to put the probe to measure the V in. Right, this is positive probe and this is negative probe. Then you just click. Then just click run button. Alright, here are your input signal for my circuit. Alright, then use Fourier transform. When you click, this is the signal in Fourier transform FFT. Then you can adjust it to get more clear, to know the result. Let I set to 6 Hz. Right, this is the value when in Fourier transform. To know the value, to get the table, just click view and click output file. So it will show you the value, which is the input value V1 for your circuit. Right. Okay, this from this simulation, this is our circuit construct, and then this is the result for VS, which is this is the graph without non-sinusoidal waveform. And then after using FFT, it will produce this. This is the output file. Alright, for our group, we measure VS, IS. This is the non-sinusoidal waveform. After using FFT, it will produce this graph, the output file. And then we measure the voltage at our resistance, which is VR1. It will produce this graph for non-sinusoidal waveform. And then after using FFT, by click this button, so you get this. And then this is the output file. Alright, which is it show the value on about your parameter in harmonic 1, harmonic 3, and harmonic 5. And then this is the voltage at C1. Then after using FFT, by click this button, it will show this graph. This is all the output. Alright, and then this one is for voltage at the inductor. Alright, when it will produce this graph for non-sinusoidal waveform. After using FFT, it will produce this graph. And then the output file that show all the value for voltage VL1 at the inductor 1. And then this is the output power on the V1. It will produce this one. But after using FFT, this product will be like this, which is the graph produce this graph. It will show like this. And then this is the output file. Right, that's all from me. Thank you.